Assalamualaikum and hi everyone. I'm Amir bin Mohammad Adnan. Uh, so I will explain about the introduction and objective about assignment heat transfer. So the first thing our group members is me, Amir bin Mohammad Adnan, my friend Ishak bin Mohammad Fuzilah, Mohammad Afiq bin Abdul Rahman, and the last one Mohammad Hamyzan bin Adnan. So for the introduction, Heatsink maintains the electronic device control thermal energy by transferring heat from the electronic circuit elements to the surrounding. Heatsink improves the reliability of electronic device due to it preventing component failure by its function. The source generates heat. This source may be any system that creates heat and requires the removal of said heat to function correctly, such as mechanical, electrical, chemical, nuclear, solar, and friction. Heat transfer away from the source. Heat move into the heat sink and away from the source via natural conduction. The heat sink material thermal conductivity directly impacts this process. That's why high thermal conductivity materials such as copper, aluminium are most commonly in the construction of heat sink. Heat distribute through the heatsink. Heat will naturally travel through the heatsink via natural conduction, moving across the thermal gradient from a high temperature to the environment. This ultimately means that the heatsink thermal profile will not be consistent. So for the objective, to design the two types of heatsink using the CAD software to run simulation analysis on the heatsink using CAD software to show and approve the temperature distribution based on the heat transfer surface at the heatsink to compare in terms of heat transfer between into different design of the heatsink. So that's all from me. Thank you.
Assalamualaikum and very good day. My name is Mohammad Hamyzan bin Adnan and I am going to present about our design for the heatsink. So for both heatsink, we use the material that we use is aluminium. So the only difference between both heatsinks are the number of fins. So for the first design, we have 18 fins. And now let's look at the second design. For the second design, we have 168 fins. So from this design, we have conducted thermal analysis using SolidWorks software. And the parameter that we set is average temperature at contact point, which is 97.3 degrees Celsius. And convection coefficient is 5.03. So parameter is the same for both design. And now we'll take a look at the result. For design 1, the average temperature at the cold side is 76.315 degrees Celsius. And the heat flux at the cold side is 291.078. And for the second design, the temperature that we obtain at the cold side is 76.267, which is slightly lower than the first design. And for the heat flux, we have obtained 240.246. So from this result, we can say that the temperature that we achieve from this design, which has a larger number of fins, is lower than the first design. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Mohammad Afiq bin Abdul Rahman and I will continue for the discussion part. So for the discussion, in order for the heatsink to function efficiently, there are several factors that need to be considered, which is material, the design, and the amount of the surface area. So for the material, both heatsink are made of the same material, which is aluminium. Aluminium is known to be commonly used by manufacturers due to its high thermal conductivity. There are other material that is higher thermal conductivity compared to aluminium, but the material is known to be expensive. So that is why we use aluminium as it has the cheaper price. Next, for the design, the significant difference between both heatsink is the number of fins. Design 2 consists a higher number of heatsink compared to design 1. Based on our analysis, this feature has affected the temperature of heatsink. Another important factor for the design is the gap between each fins. The gaps allow air for better air circulation, therefore increasing the efficiency of heat transfer through convection. The last factor that need to be considered in designing a heatsink is the surface area. Heatsink with more fins has a larger surface area. A larger surface area allows heat to dissipate through the fins with, with higher efficiency. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ishak bin Fuzilah. I will continue to explain about the conclusion. Based on the simulation analysis, our finding include thermal conductivity is important for the selection of material to manufacture heatsink. Aluminium is commonly used due to its high thermal conductivity and cheaper in cost. The number of fins in the heatsink affect the heat dissipation in the heatsink. This is proven in design 2, which has lower temperature at the cold side compared to design 1. Therefore, number of fins should be considered when designing the fin type heatsink. Design number 2 is more efficient in terms of heatsink dissipation. That's all for me. Thank you.